This video is on graphing quadratics. The graph of a quadratic function is a parabola and looks something like this. Its equation in standard form is f of x equals ax squared plus bx plus c. Recall that f of x is just another way of saying y. Also notice that a is the coefficient of x squared, b is the coefficient of x, and c is the constant term. The highest or lowest point of the graph is called the vertex. The x-coordinate of the vertex is x equals negative b over 2a. To find the y-coordinate of the vertex, we're going to take this x value and substitute it into f of x. That'll give us the x and the y-coordinate of the vertex. Also notice that this graph is symmetric about a line called the Axis of Symmetry. That's a vertical line that goes through the vertex. So the equation of this line is going to be the x-coordinate of the vertex, or x equals negative b over 2a. Recall that the equation of a vertical line is x equals a number. The x-intercepts of the graph are where the graph crosses the x-axis. Recall that this is where y is equal to 0. These are also called the solutions of the related equation. So instead of f of x equals ax squared plus bx plus c, if we set that equal to 0, those solutions are where the graph crosses the x-axis. The y-intercept is where the graph crosses the y-axis. Recall that this is where x equals 0. The y-intercept of the function is the value of c in the function. If a, the coefficient of x squared, is greater than 0, that is, it's a positive number, then the parabola opens upward and the y-coordinate of the vertex is the minimum value of the function. If a is less than 0, that is, if a is a negative number, then the parabola opens downward and the y-coordinate of the vertex is a maximum value of the function. The domain of all quadratic functions is all real numbers, and the range of a quadratic function is going to be based on the y-coordinate of the vertex and the sign of a. In other words, what direction does it open? Let's take a look at an example here. So we need to find the vertex, the equation of the axis of symmetry, and the y-intercept of this function. Then we're going to graph it and determine whether the equation has a maximum or minimum value, and then state that value. So let's start by finding the x of the vertex. Recall that we do x equals negative b over 2a. So b is 4, so that's going to give me negative 4 over 2 times a is the coefficient of x squared, which is negative 2. That's going to give me negative 4 over negative 4. So x is equal to 1. Let's find the y-coordinate of the vertex and plug 1 into there for x. So that'll give me negative 2 times 1 squared plus 4 times 1 plus 7. Or 1 squared is 1 times negative 2 gives me negative 2 plus 4 plus 7, or y is equal to 9. So that means that the coordinates of my vertex are going to be 1, 9. The axis of symmetry is going to be the equation x equals 1, because that's the x-coordinate of the vertex. And the y-intercept is going to be this value of c here. So my y-intercept is going to be the point 0, 7. Now I think I have enough information to graph this. So I'm going to go ahead and graph my vertex, which is the point 1, 9, which is right here. My y-intercept is the point 0, 7, which is right there. And I know that this is the axis of symmetry. I could actually kind of draw that in there. And my vertex is on the axis of symmetry. I know that if I have a point here, I'm going to have a point symmetric over here. And I can see that my graph opens downward, so it's going to look something like that. And notice that the vertex here is the highest point on this graph. So this graph is going to have a maximum value at the point y equals 7. Also notice that the domain of this function, even though it didn't ask for it, the domain is all real numbers. And the range of this function, in other words, what value can y be? Well, y cannot be any value. Oh, I'm sorry, I got the wrong maximum there. Sorry, not y equals 7. I'm sorry, y equals 9. Sorry about that. The maximum value is y equals 9. My range cannot be any higher. My y values cannot be any higher than 9. So my range is going to be y is less than or equal to 9. Now, here's an example I'd like for you to try. Do the same thing with this function right here. Stop the video, give it a try for yourself, and then I'll come back and show you how to do it. Okay, so to find the vertex of this function, again, I'm going to do x equals negative b over 2a. So x equals negative 2 over 2 times 1, which is going to give me a negative 1. To find the y of my vertex, I'm going to plug negative 1 in for x. So I'll have negative 1 squared plus 2 times negative 1 minus 6. And that's going to give me 1 minus 2 minus 6, or a y value of negative 7. So my vertex is the point negative 1, negative 7. My axis of symmetry is the line x equals negative 1, and my y-intercept is going to be the point 0, comma, negative 6, because negative 6 is c. Okay, so let's go ahead and graph that. So I'll graph the point 1, negative 1, negative 7. Okay, and my x-intercept is negative 6, and I know that this is going to be symmetric, so I'll have a point over here. So my graph will go like that. Okay. This graph is going to have a minimum value at the point y equals the y of my vertex, negative 7. And this is going to have a domain of all real numbers. And my range is going to be y is, since the graph is going up and all of my y values are greater than negative 7, y is greater than or equal to negative 7. So in this video, we learned about standard form of a quadratic function, how to find its vertex, its y-intercept, its axis of symmetry, minimum or maximum value, and how to graph it.